Hello everyone, my name is Netravati, studying at Sri Venkateshwara College of Engineering, subject Applied Chemistry. Today I am going to discuss about the topic that is corrosion and its control. Definition of corrosion. Corrosion can be defined as the destruction or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. Example for corrosion is rusting of iron. A reddish brown scales forming on the iron objects. Fe2 plus 2OH minus to form FeOH2, 4FeOH2 plus O2 plus 2H2O to form Fe2O3, 3H2O. It is also known as rust. And the second example is green scales formed on the copper vessels. This may occur either by the wet or dry corrosion. We have two types of environmental corrosion. One is dry corrosion and wet corrosion. Dry corrosion is also known as chemical corrosion. Wet corrosion is also known as electrochemical corrosion. Differences between the dry corrosion and the wet corrosion. Corrosion occur in the absence of moisture. Corrosion occur in the conducting medium. The process is slow. It is rapid in process. It involves direct attack of chemicals on the metal surface. It involves formation of electrochemical cell. The process of corrosion is uniform. It depends on the size of the anodic part of metal. Example for dry corrosion is the attack of dry air or oxygen on the metal to form an oxide layer over the metal. Example for wet corrosion is rusting of iron. Wet corrosion is explained on the basis of electrochemical theory. Types of corrosion. Corrosion is divided into two types: differential metal corrosion, differential aeration corrosion. Differential metal corrosion is also known as galvanic corrosion. Differential metal corrosion further divided into two types: waterline corrosion, pitting corrosion. Differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode, undergoes oxidation and gets corroded, and the other metal with higher electrode potential acts as cathode, undergoes reduction and protected from corrosion. This type of corrosion is known as galvanic corrosion and differential metal corrosion. The reaction would be: at anode, metal reacts with metal plus electrons. At cathode, 2H plus 2 electrons to form H2, or 2H2O plus O2 plus 4 electrons to form 4OH minus. Example for differential metal corrosion: tin coating copper vessels, bolt and nut made of different metals, steel pipe connected to copper pump link. Differential aeration corrosion. When a metal is exposed to different concentrations of air or oxygen, part of the metal exposed to lower concentration of oxygen becomes anodic and undergoes corrosion, whereas other part of metal exposed to a higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. At anode, Fe gives rise to Fe2 plus 2 electrons. At cathode, 2H2O plus O2 plus 4 electrons to form 4OH minus. Fe2 plus 2 OH minus to form FeOH2. Example for differential aeration corrosion is: part of the nail inside the wall undergoes corrosion. Differential aeration corrosion further divided into two types. Waterline corrosion. It is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, the inner portion of the tank below the water line is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. Example for waterline corrosion: ships which remain partially immersed in the seawater for a long time undergoes waterline corrosion. Pitting corrosion. This type of corrosion is observed when dust particles or oil drops deposited over the metal surface. Pitting corrosion is due to metal surface is not homogeneous, external environment is not homogeneous, crystallography directions are not equal in the directivity, environments are not uniform with respect to the concentration. Thank you.